Okay, good evening everyone. If you can hear me, let me know so I can just start the lesson. Uh, Backman, since you are the one with them on your microphone, can you hear me?
Yes, please.
Okay, thank you very much. So we begin today's lesson in the name of God the Father, the Son, and of the Holy Spirit. So there are Muslims and traditionalists here, pardon us. Next time we invite you to pray for us. Okay, so yesterday we continue our lesson that was on the movement of substance in and out of a cell. So from there we look at how substances moving and realize that we have active transport and also passive transport. So these are the two main ways in which substances can move in and out of a cell. And there's a last one that we call vesicular transport or bulk transport. So today we'll continue with the passive transport. We almost finished the other time. We'll continue with the passive transport, then active transport will be treated. If we have enough time, then we'll talk about the vesicular transport. So you can share with me, anyone who is ready, raise up your hand. You will tell me what you remember from yesterday's lesson. And how many of you have been able today? I decided not to notify you that I've posted the other lesson. If you're able to not see it and you have, I saw in the afternoon that 11 students have watched it. If you are one of them, you can give me a thumbs up, or whether you were notified but you haven't got time to watch it. Let me know, those who have been following on the YouTube page, because I'm recording this session as well. That is what sometimes delay me, because I have to set up 3 or more devices. Okay, if I tell, okay, Tima Kabua Tima, she has seen it. So 2 out of the 11 students I saw around 3 p.m. have shown that they've seen it. Gloria Sibu, yes, you, okay, maybe that was a mistake. Okay, someone just raised up the hand. Let me, Lillian Afriye. I think that's our class prefect in science 10. Our former class prefect, is that you? Our ex class prefect, how are you? Lillian, your hand is up, or you are just testing the systems. Okay, now just tell me what you remember from yesterday's lesson. Anyone who is ready, you can tell us what you learned from yesterday's lesson. Then I'll just continue because I'm building up on yesterday's lesson for that of today. Lillian, I feel your hand is up. If you mean to raise up your hand, talk to us right now. Okay, anyone who is ready, just tell us. Yes, Salome, your hand is up. Tell us what you remember from yesterday's lesson.
Sir, please, I remember that you told us the correct definition of osmosis and diffusion.
Yeah, thank you very much. So, can you help those who were not part of us yesterday to remember the definitions?
Yes, sir.
Then go ahead.
You said diffusion is the movement of water molecules of a region of higher concentration, a region of low concentration, until the molecules are evenly dispersed or distributed.
Thank you very much. But let me make some little, should I say correction or maybe to make it better? It's the movement of solvent molecules from, I think you said off. So let's use the right. Biology, we will mark it correct because it still makes meaning. But at least let's get the grammar correct. So from a region of higher concentration, from a region of higher or weak solution. So you don't take you confuse osmosis with diffusion, the definition. So from a weak solution, that water molecules are moving from a weak solution to a stronger solution across a semi-permeable membrane. But when you are tempted to say until the molecules are evenly distributed, that is the sole phrase or definition or the key term for diffusion, because diffusion aim is to create an equilibrium where there will be no net charge, sorry, no net movement of molecules or the substances. So that is a little thing you have to add up. Yes, we've all been there before. We used to confuse ourselves with that definition, but bit by bit, I'm sure all of us will spot out those mistakes so that we don't commit them. So it's the movement of solvent molecules from a region of higher water concentration to a region of lower water concentration across a semi-permeable membrane, or you say from a weak solution to a strong solution across a semi-permeable membrane. Thank you very much, Salome, for tuning in or phoning in to define.
Okay.
Thank you very much. I saw some two other hands up. Can you help us? Yeah. Who else hand was up? You can talk to us. Let me. Uh, Batman, if you are not talking, you mute yourself. That's her first time. Okay, any other person? I saw some hands up, but I've left that page. So if your hand is up, show it again. I'll get the notification, then I'll check those who have raised their hands up. It's 9:41 already. I want to start today's lesson. So anyone, if you have a question from yesterday that you couldn't ask, or maybe you read something on your own and you want to ask a question, you can ask. Okay, sometimes people do complain that they can't see my screen. If you can't see my screen, scroll. You see, we have some different pages. So either you scroll up or down. Uh-huh. So one of my devices, my mobile device, I've turned on my camera so that you can see me, because some of you we are meeting for the first time, because I'm sure maybe every day new member can join from a different school. So at least you need to see the person at the other side. But for you, you have the liberty to either show your face or not, because I'll be posting this online. So not all of us want to be seen on the screen anytime, any day. Okay, so you can scroll from your screen, then as I'm doing right now, then there's a point that you reach where I have shown my screen. Okay, so I think we all understood yesterday's lesson. Let me continue with today's lesson. So remember, we talk about osmosis as we define, Salome defined, and I also added some other point. And because water is moving into the cell or moving out of the cell, two different things can happen. Either the water will move in or it will move out. When it is moving in, something can occur because we are allowing more water to enter. What can happen is the cell can swell up. So the cell becomes swollen up. It becomes bigger and bigger. When it continues to become big, something can happen. The cell can burst as a result, and we call that thing hemolysis. Now, normally I use this as an example. Although you are ladies, but at least you saw your kid brothers or your friends playing football. I remember at that time we have this football keys, like the one that they play international or schools, the one that they buy. And we have one that we're calling Don Don, but I don't know how we call it now. Maybe here somewhere. It's like a tube. Sometimes it's blue, red color, very very soft. It looks like the tube of a car or a tube of some ball. Very very delicate and fragile. Normally we used to buy for younger kids. Very very soft ball. Sometimes it is green, red, it is colored, and they will paint some parts black the other side. If you do appreciate it, let me know. If you know what I'm talking about, give me a thumbs up, because you are ladies, some of you might not know what I'm talking about. So we have that board, and this more I'm talking about, it won't cost more than 20 cedis, like 20, 30, 15. Very very soft ball. It easily get bent. It's like a balloon, a harder balloon. Then we have the one that looks like the actual ball they used to play in schools and the rest. So you see that inside that kit there's a black tube. Then outside is the actual leather ball. So let me call that one a leather ball, and we have a rubber ball. But that one is very very soft. So the one with that leather around it is like the plant cell. You see, aside the tube that serves as the cell membrane, the plant cell also has a harder covering that is called the cell wall, made up of cellulose. So you see that because it has another covering, it makes it too hard and difficult for it to also to be spoiled or to be to burst. But the smaller one that we call the don don or the tube ball, it can get burst. So that's like the animal cell. It doesn't have any external casing around it, so it can easily get burst If you play it, if you clash together once you're going to play the ball, it can easily burst. So because of that, that one can easily burst. It's like inflating a balloon. If you continue to inflate a balloon, what happens is that the balloon becomes so swollen up or bigger that a point in time the balloon can burst. That's what we call hemolysis. Now, this was taken from hem, and hem refers to the blood, hemoglobin, the red blood cell. So we say hemolysis. And when you hear lysis in biology, lysis means separation or disintegration. So we can hear autolysis. You can hear hydrolysis. Hydrolysis from the word hydro. Hydro means water. So mean when water is doing a splitting. We will appreciate this when we talk about the photosynthesis, whereby you look at the dark phase and the light phase, whereby light will be used to break water into H plus hydrozonium or H plus ion, then the other group. So that is lysis. And remember, we have what we call lysosome from the word lysis. Lysosome is like a suicide bag. It also break down or digest waste substances. It can also digest itself. So we call something autolysis. That is what self killing or self disintegration. So whenever you hear the word lysis, it means splitting. So hemolysis, that means the splitting or the bursting of a cell, which is the red blood cell. So when animals pick up enough water, they become swollen up. If they continue to pick up enough water, it becomes swollen up that the cell membrane can now not open up to accommodate the inner pressure. So due to that, it can burst. But plant cell, thanks to their cell wall, because they have the cell wall will prevent the overextension of the cell membrane, thereby build creating an external pressure that will keep the inner pressure in check, and this will prevent the cell membrane or the cell itself from bursting. In that case, we say the cell becomes turgid. So look here, animal cells when they are placed in the so yesterday I explained hypotonic solution and hypertonic solution. Let me reiterate the definition. When we have three types of solution based on their concentration. We have isotonic from the word isotope. I explained this yesterday. Iso means the same. So isotonic solution is a kind of solution which concentration is the same. So if I prepare a soup and the soup is well prepared, I don't have salt beneath it or under it, and I give you that same kind of soup, yours should taste the same as mine. If I prepare a cup of tea, a Lipton or whatsoever coffee, and I give you some, and it is well stirred, and I give you some of what I prepared, it should have the same amount of milk, the same amount of sugar, if there are some other additives, it should have the same concentration as mine. In this case, that's become isotonic solution. Now, if we buy from two different vendors, one will be sweeter than the other, one will be more salty than the other, and one will be sugary than the other, depending on the food we are buying. The one that has higher salt in it, that becomes a hypertonic solution to the one that has lower salt. If it's a cup of tea, the one that has a higher sugar concentration is hypertonic to the one that has the lower sugar concentration. So this is the difference between a hypertonic solution. Someone says she can't hear me. Is she the only one? Chloe Zibu says she can't hear me. If another person can hear me, you can give me a thumbs up or you open up your mic and talk to me. Anyone who is ready. Francis, can you hear me?
Sir, please, you can hear.
Okay, someone just said she
Sir,
can.
we can hear you.
Okay, thank you very much. Okay, so those who can hear me, increase the volume of your devices, or you can exit and join shortly because we are no more than 100. Your space is still assured. Your seat is still assured. Oh, so Esther said it's at the highest. Okay, then you can't hear me at
Mine is
all.
also at the height, but I still can't hear you.
Matilda, check your network bar. How many pros do you have on your network?
Now I'm using a hotspot.
Aha, then the other device, make sure they are accessing internet. That could be the reason. So let the other device, the person using the other phone, let the person just go to WhatsApp or maybe view some status or just try to serve the web. Normally, if the other phone is not utilizing internet, it can slow down yours. So I'm sure that is your own, it's from your side. Okay, so Esther, just exit the group and join again because others can hear me. And I've joined with two devices. I still hear echo, so it means my phone is also getting the feed. Okay, let's continue. So anytime you have an issue, draw my attention. Then you can do what I've been telling you. Make sure you have a stronger internet connection, and you can also, if I talk too loud, the echo will be too much. So you see now, I've even withdraw a little bit from my seat so that the echo doesn't become too much in our uh, lesson. So another time maybe we'll find a better way. Either I'll off my screen, I'll put the phone somewhere, then I can record seamlessly without any echo. So that at least all of us can hear if you join live. Okay, let me continue from where I was. So now we understand the hypotonic solution, hypertonic, and also uh, isotonic, hyper, and hypotonic solution. So that is what I was trying to say. So now, when you put any substance or any organism in a hypotonic solution, now remember we said in osmosis, water moves from a weaker solution to a stronger solution. Now, since we are saying we have put an animal cell in a hypotonic solution, the solution contains more water, so it is a weaker solution. It means water will move from that solution or that container into the cell that we have placed in that solution. So in this case, we have an animal cell placed in a solution which is a hypotonic. Water will move from that solution into the cell. So it means that the animal cell become swollen up. It becomes bigger and bigger. If it still pick up more water, what happens? It becomes so distended and swollen that it will burst. And we call that thing hemolysis. If you understand what I've just explained, give me a thumbs up. If you understand that animal cell can become hemolyzed, so they'll become swollen up. When they overextend or distend, they become hemolyzed. A hand is up. I just want you to show, give me a thumbs up, not raise up your hand. If it's a question, don't worry, I will allow you to. Gregoria, there's a thumbs up. Go to the emoji symbol over there. The raising up your hand is to ask a question. If you are following me, I said if you understand, give me a thumbs up. If not, give me a thumbs down so that the phone in will be a little bit minimized. So I'm giving myself a thumbs up over there. I'm sure most of you will see it at your end. I want to get your feed. If you understand what I've talked about so far, give me a thumbs up. If not, give me a thumbs down for me to know that you don't understand. Okay, let me continue. Shortly, those who raise their hand, I will invite you to ask your questions if you have. So, I've still not got any feedback from you, but I do understand that you do understand. Since there's no thumbs down and there's no thumbs up, I'm sure either you are in a state of equilibrium or you do understand. So, animal cells, they'll pick in much water, they become swollen and they become distended, they can now become hemolyzed or they will burst as a result of that. That is called hemolysis. Now, what about the plant cell? Plant cell will also become distended. They become the cell will become expanded. Now because the cell wall is now rigid, because made of cellulose is a solid structure, it will prevent the overextension of the cell. So like the cell membrane want to extend because it's picking up water, and now the cell wall is trying to prevent you. No, I will not allow you to become so bigger to cause a hemolysis. So the cell wall will build a pressure that will act against the inward pressure, keeping the cell in a state of equilibrium that it cannot burst, and that is called turgid. So we say the cell wall will provide like an antagonistic pressure that will try to prevent the overextension of the cell membrane. That creates what we call a turgid pressure. It's like people are fighting, you are trying to separate them. You see the person will try to get away from your grab. You also try to hold them so strongly, firmly, that the person cannot break from your grab. That's what happens. We call a take-up pressure. So there'll be a contention among the two of you. You are preventing the person. If you're able to overpower that person, the person cannot break away to go and continue the fight. So that pressure is called a take-up pressure, and this take-up pressure lead to a condition we call turgidity. So cell membrane in animal cell cannot build a second pressure because there's no cell wall, so it can just burst away, and that's called hemolysis. But under plant cell, because they have a cell wall, it will prevent the overextension of the cell membrane, now building a pressure we call turgor pressure that will prevent the cell from bursting. So animal cells in hypotonic solution will become hemolyzed, plant cell will become turgid or firm. But before they hemolyze or they become turgid, they will all swell. But if they over swollen or they become over swollen or overextended, that is when two conditions, that is either hemolysis or turgidity, will occur. If you understand at this point, please give me a thumbs up. Let me know if you do understand by giving me a thumbs up. If I get two or three, who says she doesn't understand? Okay, someone says she doesn't understand. If someone understands, let me know. If at least one person understands, let me know. Then I will know how best to go over. Anyone that do understand now, you can raise up your hand, open your mic, or give me a thumbs up. Frederica, okay, talk to me. Your hand has been up for long. Frederica, if you know what we are doing, talk to me. If it's not intentional.
So you said that when a plant, when an animal cell is placed in a higher solution,
No, 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 no. I never said
the
that. I
water.
said no, no. Please listen. I said hypotonic solution, a solution that has more water than the solute. So let's get the facts correct. Hypotonic means it's not high. It means it's a lower concentration. Water is more, so concentration is lower. Have you got it right now?
Yes, sir.
Okay. Now you can ask your
So
question appropriately.
when the cell is placed in a lower solution, the water molecules is going to move into the cell,
Yes,
which will
please.
cause it to expand,
Yeah.
right?
Yes.
And when it expands, it's going to burst when it's an animal cell.
Yes, please.
And when it's a plant cell, it's going to be turgid.
Why will it be turgid? Yes.
Did I get it right?
Yeah, that is right. But why will it be turgid instead of bursting?
Because of the um what
The cell wall.
yes, the
Because
cell.
the cell wall cannot be expanded. It's a solid structure. It's a structural component. So it prevents you from overextending. So you are put in check. Have you got it? So I think what our sister Frederica explains it. So any other person who understands. So those who don't understand, sometimes we easily understand from our friends because we have the same way of thinking virtually. Any other person who understands or you want to ask a question for me to reiterate it. Harriet Osubuati, your hand is up. Talk to us.
That is not contribution. I just wanted to confirm something.
Yes, confirm.
Please, you say the hypotonic solution is a solution that has more water.
Yes, that's what we said.
Okay.
If it has more water, it has less salt or less sugar, so the concentration is lower. Do you get the trick here?
Yes.
Yeah, thank you very much.
So
Now,
please can you repeat what you said?
okay, she was asking that hypotonic has more water, and I said yes. If it has more water, it means the salt or the sugar is lower, therefore the concentration is low. Have you got the same idea? It's like taking a what we call it, a teacup, sorry, a teaspoon, then you put it in a cup full of water, then another person also put it in a cup that has water filled only halfway. Which one will taste more sugary? I'm sure the one that has water up to half of it. You see, it's the same amount of sugar, the same teaspoon, the same measurement of grams, but one will taste more sugary than the other because one has more water than the other. Those who don't understand, bring your question, then I'll explain again. So please, you also pay attention whenever we are explaining things. Those who don't understand, you can ask questions for me to explain. The person that said I don't understand anything, like I don't understand anything that say he's saying. I heard it by the background. You can ask a question, then I will try to explain again to you. Matilda, were you that person that said so?
Yes, but I now understand.
Okay, where that is so. So let me go back again. Esther Kumache, your hand is up. Talk to us, then I will explain again for the benefit of all of us. Esther.
So I'm going to tell you that I'm just not getting the point, but I'll go and watch the YouTube after the lecture.
Okay, okay. So now, do you understand? Let's talk together. Okay, very good. Francis has asked a question. I am for Francis. I'll answer your question there. Esther, are you still on the line?
Said please, I'll go and watch the
No, no,
YouTube.
no. I said, are you still over there?
Yes, please.
Okay, maybe someone else don't understand, so I'm using you to help others to understand. Not all of us will even talk here. Do you understand the term hypotonic solution?
No, please.
That is the issue. Do you understand the term hypertonic solution?
No, please.
It means you join late. That is the issue. Not that you listen to me throughout and you don't understand. It because you join late. I was watching. Esther will join later. Esther is off the screen, so I'm sure that is the reason why. So you can note yourself. I'm explaining for the very last time. So those who still have issue, you can rewatch or read the book. If they still have an issue, you can later ask me on the WhatsApp page, or you'll find a better way of finding me to ask.
Okay.
Okay, now mute yourself and then I'll explain for the very last time.
Okay.
Okay, so we were talking about types of concentration, and I've told you that we have isotonic solution. When we say iso means same. So isotonic solution. Okay, someone asked a question. Later, I'll go there and answer it. So when it's question time, someone should remind me. I have to go to the conversation area to answer some questions. So I have to explain that later. So let me continue what I was talking about. So ISO means the same concentration. Sorry, those who don't understand, sorry, and let me explain again so that at least your friend can also move, or else their stay here will be boring. So ISO means same concentration. So if I prepare a soup and the soup is like how do you call it, it's homogeneous concentration, it means that if I take some from the top or the bottom or any part, if I share it among 10 people, their soup should taste the same. That is isotonic. Now when you do that in the house, some of us will add some little salt into our soup. If I add some table salt to my soup, now my soup becomes highly concentrated than that of my father, my mother, or my little sister or brother. Now, when we all took it without adding a table salt to it, it was isotonic. That of your daddy, your mother, it tastes the same. But if you add salt to yours and later you taste that of your father one will taste less salty. So your father's own will now becomes hypotonic solution to yours. Now, the one that added extra salt to yours is now hyper, from the word hype, high. Yours become now hypertonic solution. Now, that is it. Now we say that osmosis, water moves from a weaker solution to a stronger solution. So if I say I put an animal cell in a hypotonic solution, hypo means lower. So that means that the solution is having a weaker solution, a weaker concentration, sorry. So water will move from the weaker solution to the higher solution. Are we getting the point here? So it means that when you put a cell, that's an animal cell, in or any cell in the hypotonic solution, the water will move from the hypotonic solution to the cell. And depending on the structure of the cell, two things can happen when excess water move into it. Now, animal cell, I explained to you that animal cell is like a balloon, or the don ball that I explained to you. That you buy for kids, it's just the tube. It doesn't contain any casing or leather around it, so it can burst anytime and any day. If you over pump it, it can burst. If you we call it, if you clash that your feet with the ball, it can burst. So over the animal cell, now it's like inflating a balloon. Sorry, I don't have a balloon here, I would have demonstrated it. If you put in more air to the balloon, it becomes bigger and bigger, it becomes bigger and bigger. If you don't take care, it will just burst. This thing has happened to all of us growing up. You will give a balloon to your brother or your uncle, daddy, please inflate the balloon for me. If they don't take care, they want to over distend or inflate it, it can burst. Then you start crying. Why did it burst? Because it had enough air or inflation to swell up. Now it burst. That is called hemolysis. So and the hemolysis, the hem part is from hemoglobin. That is a red blood cell. And the list have explained that is lysis means splitting or disintegration. Anytime you hear lysis, it means splitting. I talk about hydrolysis when water is splitting. When sunlight is splitting what we call water into H plus and O. That's what hydrolysis. So whereby water is being splitted. So anytime you hear lysis, autolysis means self-destruction, like that from what we call the lysosome. They can just, like a suicide bag, they can just bomb. When they blow up, it's called self-destruction or autolysis. So animal cell, someone asked a question, Francis, man, I say, why will animal cell best? Animal cell will best because they don't have any protection, because they continue to expand. Remember, we talk about the fluid mosaic model, whereby we realize that the cell membrane is fluid. It can open up, it can extend. The more you extend something, you will learn about Hooke's law and elasticity. When you overstretch yourself, someone says you can't hear me. If you can hear me, give me a thumbs up. I've been talking about this. Anyone that can hear me, talk to me. Matilda, can you hear me correctly? Okay, very good. So please, Charlie, check your connection as I've explained to you earlier. Let me continue. So, since they don't have a cell or a structure, they overextend. So when they go beyond their elasticity, it will burst. Like sometimes even the tire that we used to buy, that rubber band or even race band, if you overextend it, it then a tear, and the tearing is like hemolysis, that it has been splitted. So that's why animal cell they tear, because they don't have any external covering like the cell wall that will prevent overextension. Now, the plant cell, the cell membrane will try to extend, it will extend, yes, but when it reaches a point, now the cell will say, hey, chairman, you can't overextend here. There's your limit, you can't go. So the cell wall will prevent the cell membrane from overextending. So that will create a pressure. It's like you want to fight someone and I'm preventing you, I've grabbed you. There's a contention between the two of us. You want to break off, I'm still holding you up. If I'm able to overpower you, you can't go. But if no one is to check you from the fight, you go and fight. That is where the best thing happens, hemolysis. But if the cell wall is there to prevent the overextension of the cell membrane, it builds a pressure that we call a Tegel pressure. It makes it so firm that it cannot overextend to burst. So the cell membrane will not go beyond its elastic limit for it to burst. That is why plant cells do not burst. Rather, they become turgid. And turgidity is whereby the inward pressure from the cell membrane is now being acted by an external pressure by the cell wall. Therefore, it prevents you from overextending. So it becomes something very, very hard or stiff. Now, do you all understand now? Esther Kumache, now do you understand? You are the one that joined later and you couldn't understand. Esther Kumache, do you understand now?
Yeah, please, then again.
Okay, okay. Now, do you all understand the hemolysis now? Do you understand the hemolysis now?
Yes, sir.
Okay, now, if animal cell was supposed, yes. No, please, someone just ask a question. Let me finish with that. Will it be okay? So just be on the line. Vanessa, if that is you, I'll just let you ask a question shortly. So now, some are saying they understand the hemolysis. After this, please, because of time, some do understand. So I'll let you go rewatch the video, read it yourself. You should understand. It's not difficult. Once you understand the two terms, it's one of the simplest and exciting conditions in biology. So we all understand hemolysis. Animal cells, they don't have any covering to prevent them. So if something continues to extend, what happens? The thing will burst. Like balloon, you put in more air. Just buy a balloon today, or even get a rubber, then just blow air into it. It will reach a point, it will burst. But if you keep it in a container or in a hard container and you still inflate it, it will now bounce back. You see that it will not burst. That is why if you are pumping tube in a tie, it hardly bursts than when you are pumping the tube alone, because the tie will prevent the overinflation. If we put in the same amount of air pressure in a tube as we put in the tie, a tube in a tie, the tube will burst while the tie will stay there, because the tie will be like a cell wall preventing it. But if you continue to put in more air, the tube can burst in the tie. So now those who are talking about the plant cell, they have a cell wall. So it's like the cell membrane want to overextend. Now what do? The cell wall will say that no, me I cannot stretch. So when you reach me, you can't go beyond me. So it's like a security trying to prevent overextension. So let's assume there's the cell wall, there's the cell membrane. Cell membrane is here, cell wall is there. Now it's taking up water. Cell membrane try to go. If it reach here, cell wall says no man, you can't go any longer beyond it. So it is still within its elastic limit. The cell membrane will not overextend it for it to burst. So assuming if the cell membrane can reach here, then it will burst. It will not even reach that place. Once it comes here, the cell wall says no, you can't go beyond this place. So I want to go. No, you can't go. There's a contention here. This one is building an inward pressure to go out. This one is bringing, so this one is bringing an outward pressure to go out. This one say no, I'm bringing an inward pressure, I'm pushing you in. So here becomes so rigid that the cell becomes turgid. They can tell you that in P, and I pampe. Have you got the point here? So it becomes so stiffened. That is called turgidity. Now you are back. If you don't have anything in the back, let me use a sack. If there's something small in the sack looks a little bit flaccid, fragile. It can even fall. But when you go to your farm or the market and you pack things in the sack can stand. No one on earth, unless you're a magician, can put a sack for it to stand still. But when you put something in the sack, even when it's halfway, the point having the substances or the material will stand firm and the other side will fall down. But if you put things in it, you can even raise it and it will stand firm. Why? Because it is turgid. So turgidity means stiff or firm. Now Esther, do you understand the turgidity well? Or anyone who do understand now? Okay, someone said she wanted to ask a question. That was Vanessa, if I remember very well. Vanessa, ask your question. Now, at this point, if you have a question, you can ask. Then I'll move to the other side of the table. Now, we have spent more than 30 minutes here. I thought this would take us just 3 minutes, but at least once we understand it better. Frederica, ask your question.
Sir, please, I wanted to ask if the solution is is the solution that makes the plant cell turgid. So if it reached that point of like if it reached the point that it can't extend anymore, where is the solution still going to be in the basin, or it's going to enter the cell?
Okay, just be on the line. I want to understand your question. So your question is if water. So now is the water in the solution that is moving. Remember we're talking about osmosis. So for instance, I'm sure you did this example when you were in JSS. When you put a yam cavity in a salt solution, did you do that in JSS?
No, please.
Okay, then I'm giving you do this thing tomorrow. Find yam or pawpaw. So take a very big slice of it. Oh, okay, not that big, maybe bigger than one slice of yam that you eat in the house. So something like this, or yeah, like the one normally in Ghana we do. How do you call it? They smoke. I know it's not smoke. The one that they, but I think yeah. Thank you very much, roast. Thank you very much for the word. So the one that they roast, take that side. Now make a cavity in the middle. Make it go down a little bit, but make sure it doesn't pass through. Don't make it hollow, but make a cavity in the middle up to maybe 2 tiers of it. Have some little base. Now put salt as much as you want inside the cavity. Then you put it in a container containing water. you see that the next day, not even the next day, in 2 hours or an hour time, you will see that you didn't put salt in the cavity. Sorry, you put only salt. You can even add water, but for your sake, don't add water in the middle so that you can see the result very fast. Put only the salt or sugar in the middle of the cavity. Put it in a basin containing water. You will see that water will now come into the middle of it. Why is the water coming from? The water is coming from the solution. For you to be sure, you can even add a blue or maybe a dye in that water. You will see that the water that is blue, you will see a similar bluish or light blue color in the middle of your yam. That shows that the water in the basin has moved at the top. So the water from the solution is the one moving. It will move into the animal cell. Now, if it has more water, then it means that it will continue. If the water is less, the animal cell will not burst. The reason is, if the water is less, when the water reaches the animal cell, a time will come the animal cell will also become hypotonic to the solution. When it happens, water will now even move from the animal cell to the what we call the solution. At that point, we have reached equilibrium, or someone will say the water molecules are now evenly spread. But if the concentration gradient is too wide, that the water is still more, no matter the amount that enter the animal cell is still highly concentrated than the solution, then more water still want to come in, to the point that the animal cell cannot take in more water, it bursts. So it doesn't mean that once you are placed in hypotonic solution, you will burst. I first explained that more water will enter, it will swollen. If it keeps on swelling, that is when it is still having a higher concentration than the solution, water will still come in. There will be still influx of water till the point that it reaches its expansion or elastic limit, then it will burst. But sometimes it will reach a point that it becomes isotonic. Now, because very good, like you are having five, maybe the animal cell concentration is five, the concentration of the solution is three. Now 5 3 is 8. If I give you one, are you not 4 4 now, Frederica?
Yes, please.
If you are 4 4 now, who is hypertonic? We are all now isotonic. Do you understand now?
Yes.
So it will not burst. Assuming I am 18, you are also one. So it means that I have to, maybe 19, you are one. I have to give you extra 9 for us to be the same. So you see, more water will come into the animal cell and it cannot take in that much, it will burst. But if small amount of water is coming out, it cannot burst it. So that is the answer to your question. I'm sure you are well as answered. Harriet Osubuaten, you can ask your question. Your hand is up.
Sir,
Yellow.
please, I read something from my test in the morning, and then it says that the hypotonic solution is a solution of lower solute concentration. And so, sir, apart from the salt, we have any other solutes when it comes to those solutions, that's the hypotonic and
Okay, basically what we do talk about, we normally say salt. We can also talk about sugar. So when we say solute is any normally. I don't. If I bring this in here, we will get confused. Normally, we think that water is the only solvent. Solute is what is being dissolved in a larger molecule or substance. So if you add oil, oil can be your solute. Although oil is a liquid, it can be a solute because it has dissolved in the water. If I put gari in something, gari has now been dissolved, water has dissolved it. So the one that is being submerged or covered is the solute. The one that is doing the absorption is now the solvent. So if I put salt has now been dissolved. You see water, you will not see salt. If I put salt in water, you see the water, not the salt. So it means that the water has absorbed it. The water become the solvent, and the salt now become the solute. So we can have sugar, we can have salt, we can have oil. So but normally the basic one that we talk about here is salt and sugar. But any other substance that can dissolve in water will be the solute to the water. Harriet, are you okay now?
thank you.
Yeah, Mabel, until while your hand is up, talk to us. Mabel.
please, my question is the hypertonic solution.
Mm-hmm.
The animal cell that is being placed in it due
So,
to the bursting. So is it because of the cell wall of the cell membrane?
the animal cell will burst because we talk about the cell membrane. Cell membrane is fluid. It has a it can it is it can extend. It's flexible. Anything flexible can extend. So if you leave the cell membrane alone, it will extend that actually it can't take anything more. It will burst. It's like your wristband. Since it's flexible, won't it tear away? It can tear when you overstretch it. Now, is because of the cell membrane being fluid and flexible and thin as well. So when it overstretch, it can burst. But animal cell, the cell wall will prevent you that Charlie, you can't go beyond this. Now you see on campus, last time I was watching some students. I don't know whether Chewa is here. I think the day that we were preparing for the I think the how do you call that night? The Carol's night. She wanted to pick a mob from the security post. And you see around that corner, the students should not cross here. And the way she find a way, instead of going through the main street, she have to go where we have those benches over there, so that she will not pass across that line. You see, she was restricted. She couldn't go beyond that. So assuming there was no line over there, students would have just walked past that area. But because there's a mark that do not cross, if you cross this white line, it's like you have gone out without that. Most of you don't cross that line. You find a way out. So if there's a line like that, that's a cell wall that prevents your overextension. What happens to you? You can't go beyond it. So you will not go without exit and will not debotanize you or punish you. But if there's no law there, most of us will run to town, buy something and just come inside. So because of the cell wall of the plant cell that keeps them in check, they can't go beyond their limits, so they will not burst. But animal cell, there's no cell wall, no check, so they continue to take in more water, and because they are flexible, they continue to extend. So the point of no return, then the cell can burst. Mabel, have you understand the concept very well now? As I told Mabel, once you ask a question, normally just be on your phone. You can even keep yourself unmuted if you are not in a noisy area. Mabel, do you understand now? Let me talk for her. I'm sure she understands. Asibu Chloe, talk to us. Chloe. Chloe, if you are talking, then I can't hear you. Okay, now,
Please, you said.
your hand was up, or it was not intentional.
That was the question I was asking.
Okay, thank you very much. Nana Champon, your hand came up, but now it's down. If there's a question, you can ask. Okay, Chloe, Asibu, your hand is up again. Ask your question.
Please, I wanted to ask the extent that the animal cell will get to die to birth.
That one, it depends. None of the books have been able to tell us, unless maybe later you come and do a research on that, then you tell us that limit. So the point is, it can overstretch. So I've not searched whether maybe 2 times or 3 times its size. That's when it can best. Maybe later I have to do deeper reading around the hand. So it's not though. But the point is, if you go beyond how it can stretch and still taking much water, there's a point that it can best. But as of now, I can't boldly tell you that there's the point. Maybe it has to go 2 times or 3 times. So that is the answer I can give you for now. Any other hand that is out, you can ask your question. You are welcome, please. I'm waiting for 1 or 2 questions. If there's no question, I'll move to the hypertonic solution. I never knew this alone can become 1 day lesson, but at least you should understand. So I'll take my time and try to explain to all of you understanding. I thought this would take just 5 minutes, then I'll teach you the other subtopics. I'm waiting for a question. If there's no question, it means that now we all understand that under hypotonic solution is either you become hemolyzed or turgid. And plant cell will become turgid because they cannot burst, because the cell wall will create a pressure that will keep it in check called take-off pressure. Animal cell, they don't have a cell wall, so the cell membrane overextend, become distended, then it can burst if it continues to take much water. That is the summary of the hypertonic solution. I'm waiting for the next 3 seconds. If there's no hand up or a question, I'll continue. Okay, thank you very much for understanding. At this point, let's move to the other side. Go to where my screen is, watch my screen. Okay, so now hypertonic solution. Hypertonic from the word hype. So hypertonic solution, it means that the solution is having a higher concentration than what is being put into it. So if it's having a higher concentration than what is being put into it, then it means that water will now move from what is being put into it, which is now our cell, into the solution. So when you put the cell in a highly concentrated solution, since water move from where it is more to where it is less, the water will now move from the cell into the solution or container. I just pause for you to think through. So always be on your phone so that I will know. Today you are not participating very well. I don't know whether I'm not seeing your thumbs up and your thumbs down. So, and the hypertonic solution, I'm explaining again. If you do understand that, give me a thumbs up, then I'll continue. And hypertonic solution, okay, hypertonic solution is a solution whose concentration is higher than the one it is being compared with. A hypertonic solution is a solution which concentration is higher than the one it is being compared with. If you do understand now, give me a thumbs up. So in this case, water will move from the other substance put into the solution because water move from where it is more to where it is less. If you do understand, give me a thumbs up. I'm not saying it, or it's because, let me go to my actual device if I can see some thumbs up or some thumbs down. Salome, are you having a network issue? She said the next part again. Okay. Oh, okay. Sorry. So the thumbs up were coming, but I'm not seeing them on my mobile device here. So sorry. So you were talking to me and I never knew. Okay, you do understand. She said the last part again. So since I'm saying is hypertonic, and from us, that's why I took my time to explain osmosis. Osmosis, water is moving from a weaker solution. If I say you are hypertonic solution, it means you are a stronger solution. If you are strong, it means I'm weak. If I'm talking to you and I say, oh, you are the stronger person, it means I am weaker than you, you are stronger than me. So when you put a cell in a hypertonic solution, now hyper is having a stronger concentration. It's a strong solution. And now since it is hyper, it means I'm hypo. And hypo means weak solution or more water. So then if I have more water, then water will move from where it is more to where it is less. So if you put, very good, if you put let me say salted fish kobe into a salty water, when we get the tilapia or kobe, it doesn't have any salt, but we put it in salt, it takes some salt. So if I put a fresh tilapia in a salty water, the next time I taste the tilapia, it will taste what? Salty, because it will pick salt from the water. Now if I put a kobe itself in a fresh water, the next moment I will check the water will now become salty, and the kobe or the tilapia, salted fish, will now lose some of its saltiness. Why? Because water has moved into it. It has now diluted its concentration. So now under the hyper, water will move from where it is more to where it is less. So the cell will now lose water into the solution. I'm sure we understand now, so thank you very much. Now let's get to where it becomes a little bit sloppy, but I'm sure you guys will understand this time. Very simple. So now, if something loses water, what happens to it? It becomes smaller, it shrinks. That is the right word. If something loses water, it shrinks. That is why anything that loses water becomes wrinkled. Anything that loses water becomes wrinkled, so it becomes so small, cranated. So we call that thing shrink or crenation, or you can even call it flaccid. So anything that loses water Yes, hyper means high, hypo means low. I've been saying this thing continuously. Hyper means high, hypo means low. Keep that thing in your mind. Thank you very much for the reiteration. So when you continue to lose water, plant cell will lose water, animal cell will lose water. All of us become shrinked or flaccid. So flaccid means the thing has now become very very weak. It can't stand on its own. So that is a flaccid. It will lose. It's like taking a balloon. When you put in more air or inflate it, it becomes so turgid, or let me say it becomes swollen up. Now when you take in the air out of it, you see that the balloon will be so soft. That is called flaccidity, or it shrinks. There's something that happens. Animal cell, they all continue to shrink. If they continually shrink, animal cell will now become cranated. Crenation is like maybe a sweet bar or something like that, or very good. If you put gizzard in oil, what happens? See that it now become, at first it was very soft flesh. When you put it, no, let me use fat. If you take fat and you fry fat, what happens to fat? It becomes too small. Anytime you take a fat from any animal like the pork or the chicken, you see that it looks very very bigger. When you put it in oil, you see that excess oil will leave the fat. It becomes too small, as if, or those who know wagashi, when you fry wagashi, it becomes too very very small. The point is it now shrink. That is crenation. So but plant cell, they also they shrink, they become flaccid. But if they continually lose water, something happen. It's not on the screen here. I will show to you down. We call that condition plasmolysis. Let me show that one to you now. Now look at my screen now. You see this is a plant cell. Now this is a normal plant cell. You see having a very regular is it has this looks like a square or rectangle, a very regular rectangular shape, let me say it that way. Now you look this one, this one looks like it is packed. So this animal cell is here, is now turgid. So look at this animal cell wall here, this is now turgid. You see that it looks like if you are pushing more air, it has become so bouncy. That is the turgidity. This one is the normal plant cell. If this one continue to lose water, it will shrink. Now this one lose what we call flaccid. Sorry, plasmolysis. When we say plasmolysis, please listen very carefully. Plasmolysis is a condition that occurs when plant cells continually lose excess water to the point that the cytoplasmic content and the cell membrane shrink away from the cell wall. So now look at this cell membrane. At first the cell membrane was closer to the cell. Now look, it has shrunk away, and all of them have now come into the center of the cell. And when it reaches this point, it is a point of no return, because they cannot push back to their original area to form a very good cell membrane. So at this point, we say the cell has now become plasmolyzed. So plasmolysis is the extreme loss of water in plant cell, whereby the cell membrane and the cytoplasmic content pull further away from the cell wall. And when it reaches this point, it is no return, the cell will die. That is if you urinate or you put a lot of salt on water, on a plant, the plant will die as a result of it. So this is the animal cell. Let me explain this, then you have a question you ask. This is isotonic. You see the red blood cell remains the same. Now here this looks like the stomach or a balloon. You see it is now very very swollen. If more water is added again, this one will burst. Then we call that one haemolysis. Now you see this one has become like a fat that you have fried. It has now become crenated. Some books will say laking, so we call it laking or crenation. It now becomes something roughly edged because water has now been lost. It becomes wrinkled. This is called the flaccidity or crenation in animal cell. And this one is the turgidity and plasmolysis. But it becomes flaccid. There was a drawing. I don't have that slide shown. I would have shown it to you people. If you have any question, you can ask at this moment. The plasmolysis and the flaccidity or crenation. Ask your questions, then I can continue. Today we can't cover much as I expected, but it's your understanding that we want. Frederica, ask your question. Your voice is very low. Speak louder. Frederica, I can't hear you. Frederica, okay, if you're not talking, then I'll explain Salome's question. Salome said I should explain the plasmolysis again. So plasmolysis is a condition that results when plant cell loses excess water to the point that the cell membrane and cytoplasmic content withdraw away from the cell wall into the center of the cell. So the cell membrane and other cytoplasmic content withdraw or they pull further away from the cell wall to the center of the cell. And when it reach this point, it is no return. It can't go back to its normal size and shape. That is called flaccidity. Sorry, that's called plasmolysis. So sorry. It's plasmolysis. If you have a question, you can ask at this point. Thank you very much, Salome. I'm sure others have. Now, let me check some questions you people ask so I can explain. Okay, someone has a question, and I will jump on. A very good question. He says, Sir, please, it is written that all cells are surrounded with membrane, but in prokaryotic cell, it has no membrane. So please, prokaryotic cells, example bacteria. Bacteria has a cell membrane. So please, not. I don't know where you read it. So Nana Champo, if you can hear me or mute your microphone, let's talk. Let's discuss. Where did you read that thing? Maybe it's a misconception, or maybe you didn't understand very well. Nana Champo, if you can hear me or mute your mic, I'm trying to answer your question. Nana Champo, are you here? Nana Yawa Champo, for me to better explain, I want you to voice out, then I can explain. I'm still waiting for you. If Nana Yawa Champo, you ask the question that cell prokaryotic cell don't have cell membrane, I want to explain to you one on one for better understanding. If you can hear me, or mute your mic and talk to me. Okay, I'm talking. If you come in, just unmute your mic. Let me hear your voice. I will interact with you. So please, I don't know where you read this thing. Prokaryotic cells. Can you hear me? Nana, are you on the line? Okay, let me continue. So for the benefit of all of you, read what he just said to. Oh, sorry. Let me show it here. I'm sure you cannot see it. I am seeing it on my device here. So let me also show it. Okay, go to the message area. Go to the message area. All of you, you will see it over there. He asked a question that they don't have. I want to show it to you, but those of us who can see it, just go over there and view what our brother was trying to say. Okay, so in attempt to explain to Nana Achampon, you let me go over there. Let me. You do it yourself. Since I'm talking and I can't even see where that thing is. So let me concentrate on the answer. I want. Okay, very good. It's just here. Very good. I was looking for something that was just right in front of me. So this is the question that Yawa Champa was asking. So prokaryotic cells, example is bacteria. Bacteria are prokaryotes, and bacteria has a cell wall. Sorry, they even have a cell wall. For instance, their cell wall is made up of what we call peptidoglycan layer. So there's sometimes another one ask a question. Virus, they have a cell wall, and their cell wall is called capsid. It's a protein coat or a protein sheet that protect them. Very, very hard that sometimes it can even resist drug. So because something bacterial resistance and viral resistance, sometimes their cell wall can show them. They can prevent, like you take your medicine, their coat will protect them. It's like putting water at the back of a calabash. It doesn't enter. So prokaryote, example is bacteria. They have a cell wall, not even a cell membrane. Every organism has a membrane. But what this bacteria doesn't have is membrane bound organelles. So I jump on, go and read again. You couldn't come on the line, so I can't talk to you directly. So what bacteria doesn't have is they have no membrane bound organelles. The cell itself has a cell membrane, but inside the cell, the nucleus, the cytoplasm, and the other structures, they don't have a membrane. In animal cell and plant cell, we are eukaryotic cells. We are the true cells. Our nucleus has a nuclear envelope, or our nucleus also has what we call nuclear envelope or nuclear membrane that surround our membrane. Someone is giving it a thumbs down. Maybe you don't understand. Later you can tell me what you're having the issue. So cell wall is found in bacteria, and the bacteria, their cell wall is made up of what we call a peptidoglycan layer. Peptido means peptide, protein, then glycan from the word glucose. So it has glucose in addition with peptide, that's protein, attached together, that surround it. But virus, theirs is a protein sheet called capsid. When we come to plant cell wall is made up of a carbohydrate called cellulose. When we come to fungi, their cell wall is made up of what we call chitin. So by animal cell, we don't have a cell wall. So these are structural proteins or structural carbohydrates or structural molecules. It could be a glucose, it could be a cellulose or a chitin as a sugar. It could be peptidoglycan, a mixture of protein and also that of a glucose. So please, now that you are champion, prokaryotic cells, they have a cell membrane. Even to add up, they have a cell wall made up of peptidoglycan layer. But what you should have read or should have said is they don't have a membrane surrounding their organelles. They don't have a membrane bound organelle. So that answers your question. If there's any other question, you can bring it up. Someone was giving me a thumbs down. I'm sure you were not understanding. If you still don't understand, bring your question on board. Okay, so Frederica, you understand. Thanks for appreciating. Harriet also now understand. Okay, Kwabena Boache, you understand. Okay, we thank God that all of you do understand. Thank you for the thumbs up and understanding. Okay, so I've answered Nanaya, our champion's question. Okay, you can't hear me. Now, Salome, I've answered your question already. Yes, Salome, you now understand. Plasmolysis I've explained already to you. Someone said there's a scratching. Hey, Salome, sorry. If there's a scratching, try to position yourself well. If you say echo, for echo, fine, because I'm also getting the feed because my laptop is closer to my phone, through which you are seeing me. The laptop camera is not that good, so at least I want you to see me very well. If so. Okay, so let me continue. Thank God now we all understand the plasmolysis and the rest. Okay, there's a question here. Hey, so does the bacteria have cells? Charlie, the bacteria itself is a cell. Bacteria is a cell. Or you say have cells. Okay, prokaryotic cells most often they are unicellular organisms, so they are the cell. They don't have cells. Okay, now I do understand your question. They don't have cells. They are a cell. It's a cell. So prokaryotic cells, they are a cell. They are not cells. So they are unicellular organisms. Thanks for the question. They are unicellular organisms. So it is one cell organism, only one cell, and it's a full organism. Hey, Lillian, plasmolysis. So shall I, please, Salome, if you have written it, type it. Plasmolysis is a condition whereby plant cell loses excess water to the point that the cell membrane and cytoplasmic content shrink further away from the cell into the center of it. So they will shrink away, move further from the cell, and they will now converge at the middle of the cell. So that's the definition. So if you couldn't write it, don't worry, I'll upload the video tomorrow. If possible tonight, I'll edit and upload it so later you can, or you can just type in any chatbot or maybe any phone or a dictionary, they will explain it to you. But that's a good definition I've given you though. Okay, sir, sir, it is written that all cell, yeah, all cell are surrounded with membrane. Because if the cell doesn't have a membrane, hey, then how would the cell exist? So all cells have a membrane, but not all organelles. Organelle is a structure in a cell. Take that very correctly. So yes, every cell has a membrane, but not every cell has a wall. Because animal cell, we don't have a wall, but others do have their wall. The prokaryote, they have their wall. Eukaryote, that is a virus, they have a wall. Fungi, they have a wall. Bacteria too have, but animal cells, we don't have a wall, but we have a cell membrane. Oh, my network, what is happening to my network? Please, can you hear me? Okay, now my network is back, thank God. Today I've moved from my area to Kumasi, so I think where I am the network sometimes not that good. So okay, let's continue. So I came to campus today. Don't worry. So is there any other question? Then I can move on. Those who just joined, you are welcome. So if you don't understand anything, later I'll upload to the YouTube channel. You subscribe to it, then you kindly watch. It's a way of saying thank you, sir. So let's continue. Today, the way I was trying to teach a lot of things, but at least once you understand, that is fine. There's no need to rise things up. Now I have explained to you the conditions that occur when water move in and out of cells. So when water is moving in, yes, who is that? Talk to us. So is there any other question there? Those who just joined, you are welcome. So if you don't understand anything, later I'll go to the YouTube channel. Someone is giving me a feed. If your volume is on, please off it. Princess, I don't know whether your microphone is on. Yes. Try press Empire. She's asking. Is she the only one who can't hear? Press Empire. She's asking. Is she the only one who can't hear? Oh, perfect definition, Salome. Thank you very much. Let me show you so others can see what Salome just typed. So go to your screen. Go to the message. Salome just explained plasmolysis, the cell membrane and cytoplasmic content. So don't say cytoplasmic cell. Make that correction. Cytoplasmic content. So it means that all the content in the cell. So please make the correction. Cytoplasmic content shrink away from the cell wall and they converge at the center. If you want to over explain, you can add that. Thank you very much for being a good secretary for us, or let me say TA. That is good, Salome. So the only correction is not cell, it's cytoplasmic content. Hey Sarah, can't you hear me? Chloe, can you hear me?
No, we can't hear you.
Okay, it's okay, you can hear me. If you can hear me, talk to me. Okay, let me check. Let me check whether my microphone is on from the laptop. Okay, sorry, my network has lost connection. Hey, what just happened?
Yes. We can't hear you. Then your microphone is off.
Yeah, I'm sure now you can hear me.
No, it's low.
Are you sure it's a no? Can't you hear me now? Can you hear me now?
Yes, sir.
Yeah, sorry, I lost internet connection from my laptop. So sorry, I lost internet connection. I'm sure now. Okay, thank you very much for notifying me. The reason is I have muted myself on the phone so that the echo I can record, or else there will be a lot of echo and feed. So thank you very much for drawing my attention. All right. So can I continue on?
Yeah, you
Oh,
can.
we have just 10 minutes left to end this lesson. Time flies when you enjoy what. But don't worry, we couldn't cover much, but at least it's good the effort. So now let's look at some readings here to explain. Hey, can you see my screen? Let me check if my screen is still shared. Okay, let me share my screen to you. Yeah, I'm now sharing it. Don't worry. So now you should all be seeing my screen. You should all be seeing my screen. Yes, I can see my screen. So I'm sure you two can see your screen, my screen. So now hemolysis. When an animal cell is placed in a hypotonic solution, there's something here. Water will move into the cell, making it expand and sometimes burst because of the build-up pressure. Water will tend to diffuse into the cell and burst by a phenomenon we call hemolysis. So when you are placed in hypotonic solution, water will move into the cell. If you continue to move in, it becomes swollen out to a point that it can burst. That is called hemolysis. So this is just a wrap up of what we have talked to you about. Now turgidity, I talk about take-up pressure. These are all the things I explained to you. You say the cell becomes turgid. Very good. Now you see Gary, very good example. Sometimes you want to do some gas soak. What do? If the Gary is too small, you put in more water, and then you wait for some time before you come. It will now cover all the water surfaces, so you will not see any water in the Gary again because the Gary, which is the plant, let me say, is a plant structure because it has cell wall. It now pick up cells, pick up more water that it now becomes swollen. At first it was just a small Gary. Now you see them big. Let me take even rice, maybe the broken rice, they look so small, but when you put the rice on fire, you see they become so bigger. Something like oats, the grains look very smaller, but when you put in water, it now swells and become bigger. Why? Because they've taken up enough water. That is the turgidity. Beans also does that. Beans will become so bigger, very small beans like the soya bean looks smaller, but when you put it more water, it looks so bigger, 2 times its size. That is also called turgidity. Now we talk about crenation or flaccidity. When an animal cell, that is a blood cell, is placed in a solution which has a greater concentration, that is a hypertonic solution, water will diffuse out of the cell. If water continue to diffuse, we say it's become crenated or leaked. So the condition is called leaking or crenation, and that's the same as flaccidity. Flaccid means it has shrunk, it has become like very fragile, very soft. But when it becomes turgid, it becomes so stiff and we call it firm. It can stand on its own. So that is flaccidity. Now crenation. Look at the term here. Later you have the document. Those who don't have it, register on the Google Classroom. It's posted there. WhatsApp, we've been sharing it anytime, so we don't want to crowd it. So later maybe I can share for those who just join our WhatsApp platforms. These documents are there, but if you're on the Google Classroom, it is always there for you to download. So maybe after this week I'll give you some tests. Just watch out for it on the Google Classroom for you to do it. Those who just join Google Classroom, I gave 2 or 3 tests over there. Do it, then at least you will see your scores. You also try to get it done. Now, crenation refers to animal cells when they lose water and shrink, while flaccidity is often given to plant cells. They are all the same thing, but normally we give crenation to animal cells, and also we can give flaccidity to plant cell. But if you use them interchangeably, we will not punish you. But crenation is actually most often given to animal cells. Now I talk about plasmolysis. That is what I explained to you. So those who are asking for definition of plasmolysis, there's another definition here. But what I gave you better explain the process to you than this. So either you take this or what I explained to you. Let me look at this, then I'll ask for questions, then we end today's lesson. So today we can't start active transport. We have promised ourselves not to go beyond 10:09. We decided to make it 1 hour, and I asked for 1 hour 30 minutes or less. So we can't go beyond 9 o'clock. We have 5 minutes. Let's look at this. All cells use a process of diffusion. I'm reading this area where I've highlighted. All cells uses the process of diffusion to absorb and release or secrete substances. But diffusion alone isn't enough for all substances. So we have realized that cells can pick things up either via diffusion or osmosis. If they are picking water, it's osmosis. If they are picking other substances, it is called diffusion. So not all substances can enter the cell through diffusion. For water, it can always come in through osmosis, but some substances they can come through diffusion. So therefore, how does the animal or plant cell or the cell get those substances? It means the cell has to devise another way to transport it. And God being so good, someone will say nature being so good, they found a better way of transporting such substances that cannot be transmitted through diffusion or osmosis. So cells have other ways to move things across their membrane. That is, we call it, sometimes cells need to move substances against their natural flow. So it means that if water is flowing, water will flow downstream from the hill to the valley or cliff. So this is how water flows. But if you want water to move to this area, you must pump it. So if you want water to go against its gradient, you have to pump it. That is why if you are at the top of a story building, normally you have issues with water. Those down there can get water, access to water, but at the top you can't get. So remember on campus when we're having lab sessions, we're having issue with water. We have to go down to the physics lab and get water. I remember, I'm sure it was Frederica, but I said there's water at the physics lab. Yes, water is there because over there is at the ground floor. But for the water to come at the top, it means you have to have excess and a higher pressure in the tap, so water can flow from the ground floor to the first floor. We have our biology lab. So that is, if you are going against a concentration gradient, you need more power. So you will pump water or you need more energy to do that. That is, you are going against a concentration gradient. So in this case, you are using energy. That is called active transport. That is what we'll talk about, God willing, tomorrow. This is just a prelim, or that will be Sunday. So we have a very long time to meet you on this, but don't worry, just study around. Sunday will come very soon, then I will teach that subtopic. So when they are picking up substances against their natural flow, so it means the thing is many here, but I want to bring some traces to where there are many. That is, we are going against a concentration gradient. So active transport looks like a reverse of diffusion. Diffusion is like from down here, top here to down, so that they will all become equilibrium. But under active transport, we are moving it from down here so that there will be nothing left here and we have enough there. That is called active. So you need energy to do that. So this takes energy from the cell. Since it's against the concentration gradient, the required energy which is supplied by the cell, okay, this requires energy which is supplied by the cell in the form of ATP. I explained ATP the other time, adenosine triphosphate, and this is called active transport. And this will lead us to our Sunday's lesson, God willing, called active transport. So kindly, you have the documents, read around it. When you do read, when I come here and I explain, it becomes so easier to understand. Someone wouldn't have shared. I even shared this document with you before I even started teaching. I just want you to address yourself with all these things. So God willing, Sunday, by next week, we will finish this. Hopefully Sunday or Tuesday, we will finish with 5 lessons. At this point in time, we have just a few minutes end to the closure of today's lesson. Let me look at the hand raisers. Frederica hand is up, but I think Chloe hand came up first. Chloe, please, we are question. If you have a question, raise your hand now. Ask.
What will happen to an entire system?
What will happen to what? Please, I didn't hear you. What will happen to? An expired what?
unexpired
Okay, okay, very good, very good. This is a question. Yeah, yeah, a very good question, but it's not about today's lesson. So I will explain to you. Don't worry. I've had this question a lot of several times from my students. So maybe another day, either on the WhatsApp platform, I will invite you guys to ask questions. Then that will be just question and answers. Anything that baffles your mind in biology, it really helps. Sometimes we do learn a lot when you ask those questions. We think on our feet
Please, I
and
can't hear Chloe.
you can hear Chloe. Chloe was asking that, say, what happens to an expired poison? So will it still be poisonous or it will be harmless? That's a question. We will address it. But let's ask Frederica. Maybe her question is part of today's lesson. Then we do that first before we talk about that of Chloe. So Frederica, your question. Ask it. If there's nothing more, I will
Sir,
attend to here.
sir, please, I wanted to ask. You said that you gave us assignments on this platform. So how are you going to get to the questions?
Thank you very much. It's not. That's why we have the Google Classroom. So Frederica, have you registered on the Google Classroom?
yes.
No, I don't know how to do it.
Oh, okay, okay, okay. So please, always we send the links. Download Google Classroom app. If you are using an Android device, go to Play Store. It's an iOS. If you don't have a higher version of the operating system, I think it should be 17 or higher. You cannot download it. Not iPhone 17, but I mean the iOS. It's different from the iPhone model. So download Google Classroom app. Now there's a link. Now the first class is now full. I have added a second link in the messages. Use the second one. The first one was 837 nev 34. That was the group link. The second one is UTFT. Is it WRL? Something like that. I've forgotten the last three. It's UTFT WLD. That is the code for the other classroom. The first one is full. It takes 25 people. So with me, it will take 249 students in addition to me. That one is full. Use the second one. Click on the link, the second link, or you go and type UTFT WLD. I've forgotten the last three. So look at the messages. If you have issue, chat me personally on WhatsApp. I'll share it with you. So those have issue with the Google Classroom, go over there. Once you go, any assignment I put in the first class, I'll put in the second class so that you can do it. So I'll use today and tomorrow to type questions there so that I'll assess you on week 5 lesson. So either I'll wait till we finish the lesson or I'll give you short one under what we have covered so far to occupy you through the week. So that's where we send the assessment. Later on, I'll be giving you written one. So that one, I'm sure the physics page you are doing that thing. Sir gave it to you. So if it's a written and I don't make it Google form, you then write it or you type it on your device, then you upload it. That one will take more time because I have a lot of students, 250 plus, maybe 99. Last time I checked, you are over 100 in the second classroom. So over 400, 300 students on Google Classroom. I can't be marking manually. That is why I will take my time. I will do Google form. Once you finish, you have your answer. So say I've not seen my results, will now be things of the past. So Frederica, do that on the Google Classroom now. Any question on what I've taught you so far? Then I will briefly answer Chloe's question. Any other question on what I've taught today? We are ending. We are 4 minutes into the time. So sorry for that. Now let me explain. Oh, someone is giving us some feed. Chloe, you are the one. Let me mute you. Okay, so Chloe asked this question that is an expired poison a poison? The answer is yes and a no. It is still harmful. It is still poisonous. But depending on the concentration of the original poison, it will lose its toxicity. The reason is, even food, when it becomes expired, it becomes poison. Anything that becomes expired become harmful to the human body. It becomes toxic or a toxin to our body. So if a poison expired, it will still be poisonous, but it might lose its toxicity. depending on how powerful the poison was. Assuming the poison was, I don't know how they rate it, but maybe the poison was 100%. If it expire, it will lose some of its toxicity. I'm just making an assumption, maybe to 20% or 50%. So if that poison could kill any insect that come close to it, it will not be that powerful to kill the insecticide, or sorry, the insect at that very, because it has expired. It has loses its chemical integrity or potency, but it will still be harmful to you human being or some other organism, but it might not be that powerful as it used to be. But for some poison that have low toxicity, when they become poisonous, some poison could be more poisonous. So as I said, it's a yes or a no. So the point is, everything that expires become poisonous. That's why medicine, when they expire, you are advised not to take it in. So paracetamol, acetaminophen can become poisonous to you when it expires. Even the original para that is not expired has some level of toxicity. If you take in too much of them, that's why you get issue with the kidney and the rest. So every medicine has a side effect. Yes, they have it. So if you overtake it, it will build up, but their toxicity is too low that it can cause harm to your body. But when the paracetamol become expired, it will lose its chemical composition. It can become denatured. So depending on the reaction and what will occur out of that expiration, it will become either more toxic or it will become less toxic. So the answer is, an expired poison is still poisonous, but it might lose its toxicity or it might increase its toxicity depending on how it expired and its initial toxicity. Chloe, I've answered your question. If you have anything, you can bring it on board. Our time is up. I will not go beyond 9:10. So if you are okay with the answer, let me know. You can also research much on it, but that is a good answer I have given you.
Yeah, thank you.
Okay. So maybe one time I was thinking about that. I will invite you to ask general questions. So a day that we will finish early, I will ask you to bring general questions, or we will decide that on the WhatsApp page. Sometimes you bring some questions, it will push me to read more, and that is it. So in class, I love to ask a lot of questions. It's a way I also remind myself of my previous knowledge and also try to learn more. So it's a very good question you've asked. I remember some years ago, my students asked me, I think the 2021 batch of students, they asked me a question in my former school, this same question. And in fact, I love that batch a lot because they were asked a lot of questions. And today, some of them are okay, they are doing well in life because they're very, very serious. So I will end the lesson here. God bless you for being here, and I appreciate your time, effort, and you are being here. So let's keep on studying, study the other subject as well. I'll upload this on the YouTube platform. So subscribe if you haven't done that, or you are doing us a disservice, or yourself a disservice. So have a good night. Bye bye to you. See, catch you live on Sunday when we continue on the active transport. So read the lesson and have a good night. Bye.
Bye.
Bye. So those who are still on, yeah, bye bye to you all.
Bye.
Yeah, okay.